Let me check. No hearing games. Don't try this. Okay. Oh no, not this one. Hello. I hope the voice. Hello. And pin it. Right. Just try to put here. So, all right. Hello. Why the microphone looks so slow? Oh, I think now it should be fine. So GTC just added the stool format thing, so I would like to see the performance here. So actually, well, you know what the language. Someone is just telling me, he gives me a benchmark, but he's in that benchmark. I think I've just seen that today. Yeah, this benchmark, whatever. So you just do something, then do a format, right? So not this one. Don't give up. Okay, don't do that. So the benchmark looks like something like this. We're gonna for loop. We're gonna for loop the RGB, right? RGB. So if you're in the for example doing graphics programming, you're probably gonna try RGB, and then we're gonna try just print out something like stool format, right? Red, green, blue. Okay. So we can also use fast IO's concat, right? The concat function is red, green, blue, and I just benchmarked it, but I would like to also compare to the FMT lib, right? Because people love to say that library. So you can see here, I'm just compile the code on different platforms, and both of them, okay, they're compiled with native. Okay, trust me, just we compiled with native compile, native, right? Yeah, you can see here we put something like iMark native plus inter-procedure optimization. Okay, so we put both LTO flags and iMark native plus release. Okay, to just build the FMT lib. I just pour that from the latest. Just pour that. You can see I'm just pour. See, I'm pour from FMT, right? Git pour FMT is already up to date. So we are cloning the latest FMT from the south. Okay, if you don't try, we can try again. We'll try to nutrients, try FMT. Right, it's up to date. Okay, it's up to date. If you don't believe it's FMT, let's just hear this FMT, right? So what I want to just compare benchmarks to see what the real benchmark here. So actually, the performance is terrible. To be honest, the performance is terrible. So what we're gonna do? We're gonna do is just doing this benchmark. We also need to put up this enable FMT bench, because I hope if someone is just trying to benchmark this, if they don't have FMT installed or some other issues, maybe they have it installed, but the linkage might broke or for whatever reason. I just in another machine I just link on that issue. So we need to manually turn this on with an enable FMD bench here. Then we're gonna benchmark it. So after that, we're gonna put in this benchmark function. Okay, this benchmark function, despite it looks like a template, actually these four functions, they will pass by a function pointer because we can see all the parameters are same. And when we pass the name of the function name decays to a pointer. So we pass the function pointers into the function. Then we're gonna benchmark it. Okay, after we benchmark it, we get a size. So the function won't be inline because there's no point, right? It's a function pointer. Why would you do that? And we're gonna call it. Each time when we call it, we just concatenate a string. Then we get its size, and return the total size. We just calculate all the size of RGB. Okay, all the string here. Then return a offset of timestamp, which is to measure how long it is, right? Okay, I don't think this much larger thing here. We can try. So we're gonna just benchmark it. Okay, you can see I'm enable all the optimization tower. Okay, all the optimization tower. So let's just try it. We're gonna try for two times. Okay, we're gonna try 2 times. We can try another time. Okay. Now you can see. Okay, the stu format takes 1.66 seconds, right? But if you look at FastIO's contact, it only takes 0.233560413 seconds. Okay, and FMT, you might say, what about FMT lib? It takes a second, just a second, right? You might say maybe it's because we need to compile the format string. So at runtime. So I put the FMT compile too. So I include the FMT compile to just FMT compile because a lot of people say, hey, the cost just comes from parsing the format string. Despite it's not, okay? So here we have a red, green, blue. It's FMT compile, which is they're gonna do that at compile time. But even with that, we can see the gap between not putting FMT compile and FMT compile is very small, and FMT lib is nearly 4 to 5 times slower than FastIO, 4 times, more than 4 times, just a little bit above 4 times. 4 times slower than FastIO and the concat function. And if you look at stu format, it takes 1.6677. I think the real gap is probably even much larger because we know that when we concat the string, or we do something with string needs to allocate space on the heap, right? And heap, it must be thread safe, plus there's a lot of other overhead around the heap. So the heap allocation takes a huge amount of time here. And we can see in this case, okay, here in this case, even the heap allocation takes so much time, the FastIO actually have an advantage of 4 times or 3 times some kind of performance gap, right? You can just nearly 10 times. Okay, nearly 10 times slower. This is nearly 10 times, 8 times, right? Just even it's not at the same, right? Just magnitude, right? One is 0.25, which is 0.2, blah blah. One is 1 point several, right? The gap is very large, right? It's not a small gap. This is GCC, okay? This leads to C++1. Now maybe we're gonna try, for example, clan. Okay, we probably can try clan. Okay, we're gonna try clan, but I think if we're using clan, we'll probably not be able to use link time optimization because I think we can probably do LTO, but not that part. Or we cannot find LFMD. Oh, that's because we are not linking to a correct library. We need to put put here. Actually, there's something wrong with the client is that it doesn't find our native compiler. It just try to find somewhere else, which is extremely annoying. I would say just extremely annoying. I'm gonna put here home features. Okay, you win. I've said you win. You've won. You've won. Okay, you've won. Okay. Maybe its issue is yeah, it's not an issue. Okay, so sorry about that. I cannot. Wait. Yep, we can do something wrong. Okay, we just do no std in C++. Don't put error here. I here. Okay, I here to put include here and put C++ here. We also need C++, right? Because we need C++. Then 13, right? 13. Then I'm gonna put L flag, which is where our library is located. So this is something quite annoying with the clan. I feel it's just super annoying. Now we need to first put that one and put it in the 32-bit one. Right. Oh yeah. So we're gonna do here go C++, go 13, go bits, right? Go this one, then go bits. Okay, we're gonna go here. Yep. I think this should be enough. Built-in launcher? Built-in to upper. There's no built-in to upper. Okay, we need to report this bug to GCC to say, hey, you don't have built-in to upper. Okay, so this built-in function does not exist. So we're gonna report to GCC. And we can just, after that, we're gonna manually first fix it, but we're gonna do it later. Built-in launcher is not allowed. STD format does not work for plans. Alright, I'm gonna report this bug because just this feature just added very new. We could just add it today. We just don't do that. We just put that here. Okay. Oh, they probably want us to do something. We're gonna just x86 Linux gonna doesn't want to work. And then we could ask Jonathan Wickley to do that. Sorry about that. I cannot test you for clan. I'm probably only gonna do you for. Yep, we're gonna only leave C++, not leave std C++. Did I put? Wait. Oh, we cannot do no std in C++ probably. I don't even remember where did I install that one. Sorry about that. I cannot test it for you today. I forgot. I just completely forgot what's going on. Yep, just ignore here. Sorry about that. It's a bug in GCC. It's a bug in GCC. Yep. Okay. We can probably first fix it, manually fix it, but why would it do to upper, right? To upper is bad. No matter. Built-in to upper. You shouldn't use to upper, to be honest. It's just bad. CPP has built-in, right? It has built-in. built-in to upper, we do something like this, or we use stu to upper, or we use to stu to upper. Actually, you shouldn't use stu to upper either, right? Because this to upper is just super wrong. Because it's gonna get affected by locale, which is just wrong, right? It's just wrong. We're gonna also have this built-in to upper is one thing, and another is built-in lambda is defined here. No float 128. Oh, 28. So clearly GCC. Oh, okay, it's because client doesn't have this float 128 thing here. What was the flag I added for float 112? It's pretty bad, you know, just pretty bad with the situation of F. Yeah, float 128. Float 108. Yeah, this one I think. Yeah, std float, right? Std float. We can just do something like this. Here we go. We're probably gonna work. Yeah, this works. But it cannot find FMT. Okay, you cannot find FMT, then we have to manually link it. Okay, which is not good for sure, but you don't have a better solution either. Native one, yeah, we could just put here and put leave fmt dot a. Oh, so yeah, that's why we cannot find the library, because when we do something like LFMT, we didn't actually it's right. The path is wrong. It should not be absolute path. Yeah, this one should be okay. All right. Sorry about that. Cannot test it. I don't know what the okay with the assert fail thing here. I just mentioned that I think hi hello. So this is ridiculous. This is completely ridiculous. So you cannot do this with client. Okay, let's just try GCC, because yeah, if client doesn't work, what I should do? I cannot help you anymore. Okay. Okay, benchmarking again. Then we're gonna go back to Windows. We're gonna see what's going on with Windows. Okay, so here we will benchmark. We've done with Linux. We're gonna try Windows. I'm streaming to nobody. Okay, you can say whatever you want. I just use that as a recording a video instead of just uploading again. Right, just save my space. So we're gonna try with client plus. Oh, first try MSVC. Okay, we're gonna try Microsoft compiler. So how long it will take? It doesn't have FMT. We're gonna try FMT later, because I didn't compile with Microsoft with for MSVC. I don't want to do that. It will waste my time. You know, it's completely waste my time. It's not that bad, but it's still bad, right? It's 2 times, right? The reason why it's not that significant as Linux is because the allocator, the malloc, on Windows are very slow. So if you call new, the new is very slow on Windows. Probably even, I think it's probably 10 times slower than Linux. That's why you see that result, okay? Also, the optimization isn't very good for Microsoft compiler either. That's why we enabled all the optimization. It's not as optimized as client. We can client, if we put client with Microsoft one, we can have all sorts of optimizations. I'm gonna try it later. I'll try it again. Oh, if we try to climb with this one, we're gonna encounter the same issue, right? Because there's no to upper. Yeah, we're gonna try GCC. We're gonna try GCC. Okay, you can see if we compile with clan, then through format is now 3 times slower than FastIO on Windows. But actually, I did another benchmark. Yeah, we can now try, instead of trying, wait, which one? Yeah, this one. Yeah, we don't do this, we just do that, right? Because the default target for this clan is yeah, we can see we have the same issue as it was on the Microsoft compiler on the Linux. So we cannot do this anymore. I guess it is probably not going to work on Linux either. On this one either, because who knows what's wrong with the FMT lib, right? Just I don't know what's wrong with the library. The library does have issues. People love it, we go here. Go C++, 13 format. Trust me, it's gonna run very slow. Even just the to upper function is going to kill you. I'm sad the to upper. Hey, see here, the actual cost to upper here. Now he's called built-in to upper. Just call to upper. Doesn't matter. Or probably we're gonna try if they call built-in, we have to use it as built-in to upper. Then we're gonna do stud to upper. Oh, this we didn't enable FMT bench. I'm gonna link FMT there. I don't know why it could compile. It cannot. I don't know why. Okay. I don't know why it is saying undefined symbol. I know. Probably because LTO thing here. Probably we just cannot use LTO. We have to use the GNU linker. Probably is going to work. Oh, you cannot find either, right? Just the linker doesn't find the thing here. So sorry about that. It's just for fun, but it's not working. So we cannot do that with clan. We cannot compile it with clan, but we can compile it without the FMT lib. You can see how many issues with the library, right? This what people hate is just I don't know. Yeah, it takes me nearly 3 times, right? It's near. Oh, probably because before we use the same as mRCognitive here. Yep, it's gonna take us. Yeah. Oh. Actually, the mRCognitive makes the library a little bit slower. Okay, it doesn't matter. You can see it's 3 times slower. Whatever. It's just 3 times slower. Hello? Nobody's here. Nobody cares. So we're gonna try G++. We're gonna try G++. GCC. We're gonna do this. We're gonna do that one. Oh, now we can do enable FMT bench. Yeah, I think it's probably the issue with LTO, but whatever. So if we want to use LTO, we have to recompile. Okay, it's working now. See here is 5 times, right? 5 times. FMT take you 2.1. Okay, it's slow. Not this in this on this platform is 4 times, but on Windows, since the allocators are very slow, the gap is dropped to, you can see now FMT compile actually runs slower than FMT without compile now, you know. But we can do something like to change that with mmalloc, right? With mmalloc. So that's something what I want to try. So we're gonna go here. We're gonna copy the path. Copy the path here. We're gonna try mmalloc. I've already compiled mmalloc. We can just try the mmalloc here. Just compile it with it. Just put it here. Compile is very, very slow, right? You can see the binary size is also extremely large. Okay. So here we have to link it, because we didn't link mmalloc. We have to do this. Okay, we'll do this one. Okay, we'll link the dynamic linking to the mmalloc.dir. Okay, it's working now. Let's just run it. It's probably running much faster than it was before. Yep. You can see here the fast. If you see fast cells contact, it improves nearly 100%, right? Because the cost is the most cost here is allocation cost. Now you can see the performance gap is 7 times on contact compared to slow format, right? So fast cells contact, it runs 7 times faster than slow format. So why bother use it? And then we can see the FMT format. We probably can run again to see whether it's some other issues. I don't know why this runs so slow. It just feels so slow, you know. You can see the FMT lib, even with FMT compile, it runs at least 3 times, right? Without compile, it's probably even larger. But you can see how large it is, right? Just very large. The gap is very large, right? We'll try clan. We can try clan too. We can try clan with the same thing with the mmalloc. Let's just try. If we compile with clan, what's going to happen? Okay. Yeah, it's definitely an issue with FMT lib, whatever. Probably because I compile with LTO. We shouldn't compile with LTO probably. Did we just compile? Okay, looks like client doesn't understand this one. So yeah. So when the binary is compiled with LTO, it's probably not binary compatible anymore. Something like that. So here we have to put a flag here and then put some sort of include. You need to include this path. Yep. LTO. You can see I've enabled all the optimizations here. Is it working now? Yep, it's working, right? So the gap is 8 times, right? It's 8 times. Yeah. So yeah. You can see the performance gap is 8 times that large, you know. It's extremely large, right? It's just extremely large. Yeah, I understand. When we LTO compile an object, and the client doesn't understand it. The client doesn't understand that why it has a thing. That's why we didn't see kind of compile with FMT lib here, because I just compile with LTO to ensure the performance we get is the fastest one you could get from FMT. So you're saying I'm cheating, right? I'm not cheating, right? I'm not cheating at all. You can see it just runs very slow, right? Just the entire thing runs ridiculously slow. It's just slow. It's very slow. The format is slow. Okay, stop defending your format string, please. Okay. So we're gonna go back here. Go back to the code here. Now we have the benchmark. So what I want to try is what's a binary size here. Okay, what's a binary size here? Now first we're gonna try something like this. We're not going to do this. Okay, not going to do this one. We're not going to do compile with MIMA. We're just trying to see binary size, and we're not using FMT either. We're gonna just see the binary. Probably we should add a micro to say disable format bench for std bench. Yeah, we're probably gonna do something like this to show, hey, I do have the bench here. So we're gonna copy every lines of code here. Okay, we can just enable a micro here. We can just instead of just doing something like this, we can just do disable std format bench. If it's not compiling anything wrong, we can. I don't think we did, because if it did, it shouldn't. Right? It just shouldn't. Oh, not defined. It's not defined. Okay, it's not defined. Right? Yeah, you can see even the compilation speed gets much faster. So I just fail to see the point. I just feel it's just ridiculous that the standard did. The standard just did a horrible job, right? Disable add flag micro, allow disable bench micro. Right. Then we're gonna go here and try to contribute the code here. We're gonna put here, merge the code here, merge the bench, go back, sync it again, then port it again. Then we're gonna distribute it to other platforms by doing this push. Okay, another done. So with the benchmark, we see, let's just see. So what I've static compiled. First, let's just try dynamic compile. We'll try dynamic compile. We try dynamically compile. It's 23 kilobytes, right? Now, if we static compile, you're gonna see 99 kilobytes with fast IO. The reason it's not coming from fast IO, it's coming from the string. Right, we use the string, and the string will add 70 kilobytes of binary size in the standard library. Okay, so this is the problem with the string. So if we try something like, we're not going to do that. We're going to just not disable std format. What is a binary size? Okay, from 99. Okay, what's the 89? Okay, 89. 23 to 89. Okay. What about static linking? $950, dude. See this? 950. Now what about FMT, right? We can first just try to see what's going on with the FMT. We just compile FMT. We just enable FMT bench, for example. What's going on with that one? Okay, we need to put. Wait, don't do that. We're probably gonna do with one, but you shouldn't do it. Okay, it's 500. It's LTO compiling. Well, you can see the FMT just bloat LTO, right? So it's 812 static linking. Okay. So it's from 900. So the FMT would take you 800 kilobytes, dude. So we're gonna add everything together. Just then we static compile. We're gonna see how large it is. See the binary size. Just too much dead code in the system format thing here. People like say, hey, it's just saving your binary size. It's untrue, dude. It's just untrue. A megabyte. Okay, it's 10 times, at least 10 times. Right? I'm just even exclude part of string. If you just completely exclude string for you to write your own string with fast IO, then you won't pay that string at all. I would definitely write my own string type. I would never use to string because it blows my binary size with all the problems that are there. So you can see that it's just ridiculous, right? Even the binary size is 10 times or whatever, just very large. It adds megabytes of binary size. The binary size is large and the performance isn't good either, right? See, I have enabled LTO, mark native, and in fact, while cross compile the library on the center, I also enabled LTO. Right? You cannot justify it, to be honest. You cannot just justify the performance here. You cannot justify the binary size here. It's just so slow. Our world is so slow because we have these people. They have no idea what they are doing. You suffer from performance, you suffer from security problems, you suffer from... Oh, let's just try another thing which is quite interesting. Probably they haven't enabled that patch. We can try double format string. Yeah, I think FMT doesn't allow you to do that, but probably standard library can still do that. We're gonna try something like... Yeah, we're gonna scan the string here. We're gonna use fast to scan the string. Alright, we're gonna scan the string. We're gonna scan the string. So just stop using string, to be honest. The string is terrible, just really terrible. So we're gonna do is something like std format. I probably have std print. Probably have std print. I'm gonna see what's going wrong with that one. They probably do have that one, right? So here's the one thing, right? Just the introduced problem for me is that when they add, what's going on when they add the thing which have, if someone using using namespace in here, I'm just not going to support that. I guess some just make it mad, okay? Double format str. Oh, not one. So, but we can still do something like println stu format, right? Printed, not doing println. Just println, okay? We probably can do something like str. Oh, okay, it's not usable. Yeah, context per expression. They've already not enabled you to do that, okay? Let me see. How did they do this? Okay, I would like to see how does they do this? How does they do this? Gonna go GCC. Maybe C++20 is going to. You can use it with C++20. Oh, no, not C++20 either. It's not a format. Let's just try. Format. So 300, 800, 300, 8. Okay. Checking scanner. Oh, basic format string. So it's no longer the type here, it's the checking format string. Then it's not context per it's not usable in a context per expression. Hey, but if what happens if I use string view? Oh, not either. As a context. How is that possible? That's something interesting, okay? It's not usable in context. Is there something they use something built-in, whatever the compiler is able to do that? I don't think the compiler can do this. They have to do something, right? You cannot just say, hey, you have that one. A format error. Or about. Whatever, just. What about the constructor basic format string? Convertible to string view. Conceval. Oh, if we put a conceval here, then it must be evaluate compile time. Right, so it has to be evaluated compile time if we're gonna put a conceval here. So the okay. Basic string view. I think we can still do something we can get around with it, right? But for example, we're gonna do something like basic format string char. Okay, std the basic format string. str2. Then we're gonna do a memset. I'm gonna do a because it's probably not going to work, but we're gonna try memset. Memcopy. Right. I'm gonna try size of. We're gonna try building. I'll just try this. Okay. See whether we can get it wrong. Okay. Build. Hey, it's basic format string. Okay. Oh. Not working either. Oh, format. No mention function call. Hey, you have to put a format string here. Okay, then we put something like this. I can guarantee we can finally get it wrong. Not going to work. Basic format string. Oh, we can not format string. Format string is not printable, but so what's going on? What's the parameter here? Format string. Conceval. Yes, this works, but the next one probably not. Where's the function here? Locale. Okay, they have also used locale optional. Why? Why would they use optional? Format ranges. Counting sync. Formatted. No discard. Format string sync. And you have all this crazy amount of abstraction, but in the performance end up so badly. No, format. Yep. Right. Format context. Format string view. No, this formatter, right? I don't even see where the function is. Where the function? Where's the function? Where is it? STD format. Where is it? Require hosted. Is the hosted okay? Not like FastIO, which is freestanding one. Oh yeah, this I think I missed something. For the FastIO is that I should add a function that could accept the C style string, the C array as a parameter for reading a string. Right? Sometimes people do need to read string on a stack, not read on a toString. Right? So that will be very, very important actually. Let me think. Yeah. But calculus is probably not good, but reading string should definitely work because IOStream as SDIO supports that. Yeah, we should add that. Where's the basic format string here? Oh, just so many types, dude. Just so many types. And anytime if they change something, they can add a new type. Then you have ABI break, right? You have ABI break, unfortunately. When link them together, it's gonna create ABI issue, right? It's definitely gonna create ABI issues if they add a new type, right? Because that's exactly the problem with format string. The function is still there, right? You only have that function. If you add something, it's going to crash, right? It's going to crash, right? Yeah, it's going to crash, right? It's definitely going to crash. If someone is linking to an old library, then you link to a new library, and then link them together. You won't see any bugs. You won't see any compilation issue, but they actually link to different function. They're gonna get crash. yeah, that's going to happen. It's ridiculous, right? It's completely ridiculous. Format. Where's the format? I just don't see the format. Yeah. Just too many format. 800. The 800 formatter. Namespace formatter. 800. Did we see the format? The function format. It should be this function, right? But it also looks like it's just optional locale. But why would the bloat spider say it is optional, right? Basic string view. Format parser. String view. To do C++20 escaped. Entire thing is so complicated, dude. Entire thing is so complicated. Right? People are just making things worse. Right? That's exactly the criticism I have to format string. You're not making anything better. You're just making things worse, right? You're just creating all the crazy things. Oh, ASM. Okay, you're gonna use ASM micro to just rename it. Alright. It's just crazy, just crazy. The library is crazy, it's so crazy. Format. It's compiled slow. It has no thoughts on anything, to be honest. Right. Sorry about that. I just try to find the format function. You can see with at least 20 minutes. But I still cannot find that. I don't see where the function is, Where's that function? Just so far, it's so hard to find it. It's just so hard. It's just finding that function is so hard. Right? It's just so hard. Format size. The entire thing is so complicated and chaotic, right? It's just so complicated. Okay, so the short answer is that just don't use it, please. Okay. Well, this is probably better. It's just after my criticism, but actually we can still get it around. You know, if you think, hey, this I'm not going to get this around, I could, right? It just very easily can get it around. Like I'm going to define a micro. I'm probably going to do something like people are going to do something like if on def and some sort of output micro, right? Some micro. I just define a micro. I can still defeat it, right? I can defeat from outside. It's not like you said I cannot do this, right? I can still do something like this. You cannot defend it. You cannot actually defend, right? Something like this. We're gonna do something like this. You cannot prevent it, right? You cannot prevent this one. I'm a micro. How can you compile to? How could you defend it? Right? So what we're gonna do is we're gonna define something here. Define output micro. This is very common if you think of the right the compiler team will do, right? The compiler will think all those shit like this. An expansion with a micro. Why? Probably gonna do something just to this. Missing micro. Probably. Yep. How to define micro? I don't know how to define a micro string. Define an output micro. Define a micro string. Define a string micro. C define micro string. Define a micro from outside. I actually did that. Let me check how fast I did to define micros. You can easily defeat the code if you think like you have build system that gonna do this. Gonna still gonna break it, right? There's no solution to really fix the issue. Right. So here probably we cannot. Or probably this one should. I don't think so. I don't think why you put that here. To mesh output micro. What is the content micro output micro? You probably need to put this non-expert function. Invalid arg ID. Oh, it's okay. Let me first try 3. Let me first try 3. Oh, the format string is not right, but we can do something like 0, 0, 0, 0, 0, 0. This should work, right? It's not illegal, right? Here we go, right? And we can also do. It's so easy. You don't even do anything. Just do 1, 2 to the. That's 1. Okay. We're gonna crash. Just crash down, right? It's so easy to defeat it, right? Even if it says it's illegal, we'll try 3, gonna try 1. We'll just try 1 whether 1 will work, right? Right? You can still defeat it, right? Because it allows you to swap location. It allows you to do these things, right? Think of it. What's going to happen if we keep doing this? What's going to happen? I think I should put a video here to watch it. Think what's going to happen if we keep put this. Right? I've already defeated. I think even this symbol string gonna work. Defeat the format string. And we don't even need double format string case to exist. Okay, it's already crashed. If we just try 3, okay, someone will just, I'm going to just format 3 or just format hello world. Okay, nothing, you don't see anything wrong here, right? Now we're gonna try this. Yeah, probably because it's format error. Probably because format error. Probably we're gonna catch exception. Probably it's EH. I think it's probably EH. Okay, it's probably in EH. But we still defeat it. As long as we just keep doing this, we can finally reach to a point that they're gonna crash without EH. Because you're gonna overflow the entire system, right? You can overflow it. Not mention you can still do something. They still allow that, right? They still allow that. Oh, we shouldn't use this. I think they probably have a maximum value like 1,000 whatever. We're gonna try replace. Okay, what about this? I think this should not have issues, right? Defeat micro. Now, if you can just hijack the build system, right, you can still attack formats, right? Right, because people do use this build system to generate something, right? So there's no real solution to prevent the issue here. We're gonna see the code really wrong here. Okay, nothing. Now we can keep doing that. We can keep to the point. You cannot do this, right? 6-5 high. It's going to be way faster if we have double format entering attack, whatever. Well, this one, what is the maximum value? I don't know what's the maximum value of the N here. You understand my point, right? You cannot finally attack it. Well, let's see what's the value. The value here. What is the wide? Purse wide, right? How large it could purse? How large it could purse? Format error, precision. How large it could be? A purse. I don't know. It's a purse integer. How large it is? Will be small. You cannot guarantee that, to be honest. 31. How do you know that? To be honest, you just don't know. Right? You don't know. The fact is that you don't know. Unsigned short. So the maximum number is unsigned short. So let me think. You're probably gonna put a lot of this string. Because this Windows have the command line, the restriction of command line. I don't know whether Linux had that. What you're gonna finally reach to a point that you cannot do this. You can still do this. Well, just a bunch of this one. Like you can think it might just overflow. Right? You don't even know what's going on, right? You don't even know what's going on right now. So yeah, you can still control it. You can still control this one. Right? I'm just doing an outside control. So there's no real solution, dude. Don't tell me it's too small, right? what's going to happen if it is large. So I just don't believe we cannot. Yeah. Try it. 0266. Oh, well, probably. This should be enough, right? If we after overflow to 4 gigabyte, we've already overflowed the 32-bit one, right? Probably we're not going to do that with 32-bit, but oh, this is the maximum length. If I remember correctly, GCC allows us to put extra values in a file, something like that. So you can still continue to put flags to the point that, yep, you're gonna finally attack it. You can just always attack it. I don't think there's restrictions on Linux. I'm not going to try that because it's going to crash my membership. But we can try to just compile it. We'll see what's going on. It's going to compile the code. You just compile this one. Because it's Windows, you're probably not going to. And if you're living in the, if they do for something like runtime format string, you can still attack it, right? You can still easily attack it. So you can always attack it. Trust me. But particularly people would make the argument they use it for runtime. Whereas the format context, all sorts of things still exist, right? It's not actually getting away. Let me go 10. Okay. Just too many things here. To the point it cannot compile. Maybe if someone's creating process, something like that, I don't know. Oh, we can use a bash command. Bash. Maybe CMD could work. For example, you're running a script. It maybe even works on Windows. Let me see. Okay. Not bad. It's a bad file. File is not specified. Okay, where is this one? The file is not specified. bin.bash. What happens if we try bash? sh something like that. I just feel that it probably is because the format string. Yep. Line 1. Oh, looks like we need to put something like. Let's just assume we have already compiled this possibly. what is the first line of the bin bash? Yep. If we're gonna use bash, we're gonna put the first line here. Why? Is there anything wrong here? Okay, it looks like it's because it is too large. If I remember correctly, GCC allows us to put fires here. So we can put fires, and I'm gonna read fires. Yeah, it's probably going to work. Oh yeah, it's working. It's working, right? It's compiling. Okay, then I'm gonna crash the system. After we did all the shit like this, gonna crash the system. Don't do that. Please don't, okay? This executable is going to crash your system. Okay? Let me just try whether we could run this fire on Windows. I think we could. We actually could. We actually could run it on Windows. So if right. So there's no real safe solution, right? There's no real safe solution. Finance, yeah. I cannot executable. No create fire. Okay, looks like some box here with create process. Probably it's my sys2 thing here. Yep. Okay, bug. Okay, just really bugs, just bugs. This is just bug, dude. Just bug. Clan. What about clan? Yep. Oh, it's digit. Expand here. C hype. Whatever. What's going to happen if we run it? Please don't. Okay, it's not because the memory is very large on that machine. If we run Linux, please don't do that. Okay, please don't never do this. Okay, this is crazy. You know, it's just gonna overflow memory. Right? It's gonna find overflow memory. Right. Okay, so if you can also, you might think, oh, this is probably not going to work because the string is a lot of one. But think of it, you actually don't, right? If the string itself is very large, right? For example, then you can still attack it. You can always attack it, right? It's so easy just to think about it, right? If we just put something like a string, if someone is doing something like str, this scanner string. So what you're gonna think of it is be very difficult to attack. It still can attack, right? So you will still attack it. Plus, they actually don't always force you. Okay, so they still allow you to do that. You know. So they still allow you to do format context. Format context, V format, right? So it's equals to V format, right? They've told you that they have V format, right? They're gonna do make format args. Okay. Yep. Then someone's doing something like this. Okay, you might say, hey, they probably not going to do this anymore. How do you know? How do you know that? Right, this is still gonna do that. Okay, so let's just try what's going on with this code. Double format string. I think they really should have better solution instead of this one. Just ridiculous, right? Just ridiculous, right? You have double format string. What's good? You're gonna run again. Okay? It's gonna run it again. I really love this example art. Oh, right. You can still attack it, right? Now you have infinite amount of attacks of it. You can't actually be 100% safe. I'm doing the safe thing. I'm just doing as you think is safe, but right, double format string. How are you gonna defend it? Instead of doing this, I'm gonna do that in a fire or something like that. Right. Someone just crafting a malicious, just this one, right? We just craft this malicious code. This malicious code. Just gonna just use this. Right. It's gonna run forever. It's gonna run forever. See my memory usage. We don't even get a crash. We probably even not be able to get any crashing. No crashing. It's killed, right? Probably the process killed probably. Fires, double format SDR. What is the process doing, dude? It doesn't do anything. Right. Denial of service. Just basically denial of service. Nothing. Oh, sorry about that. Yeah. Okay. Let's just watch a gigabyte. Looks like it's not enough. Continue. Continue. Let's just continue. Okay. I don't believe we cannot overflow this one. Yep. 6 G, 13, 18, 14, EH. Okay. Yep. So you can still attack it, right? You cannot be safe. Just the string can be anything, right? Just it can be another string. Right? Then you can construct this vector to attack it. Right? You might say it's probably not going to work. Probably, but in reality, people would do something like STR, right? Then you encounter that kind of issues. So you cannot actually prevent them. You cannot prevent these issues, dude. Right? Another reason why string is sometimes harmful is because it can do something like this. It's gonna allocate space. Out here we're probably gonna see EH gonna bad alloc. Probably some reasons, right? I think bad alloc is thrown. Why would they throw bad alloc? Right? No matter. If on Linux, you're probably gonna just see your process get killed, right? Just kill your process. And you just see you're probably just running some critical server and just crash down because of that. So please don't use format string. Sorry about that. Microphone. Is that still low? Is it still low? Let me see what's going on with it. Is there anyone watching it? I don't see anyone is watch this one. Deactivate. No, no. Oh, not it. Nobody is watching. So, yeah. So you can attack it. Just don't trust those people saying you cannot attack it. You can still attack it. They can trigger overflow. They can using micros. They can do a lot of things. Right? Even when you put all the restrictions, it's still broken. Right? It's still broken. Not mentioning people would do that wrong, right? You can have some other issues, like my favorite example would be, hey, I'm doing something like, or int AT probably not going to have the issue, but maybe okay. Maybe someone is defining their my int AT to be char star, right? It can happen, right? To be my int 8. You'll see that's very common in some C code. And then you're gonna do something like, I define a pointer to an object, a B, right? They're gonna define a pointer to the B. Nothing wrong, right? People would normally do this, and you're gonna have issues like, what's gonna happen? Okay, sorry about that. So, what's going to happen in this case? Oh, you can see compilation is very slow. Wow. Oh, we should define it, right? My int AT is too large. Now we'll just try 126. I don't think it'll be very large, right? So, it becomes very weird, What I'm printing integers. I'm thinking it's an integer, I'm thinking an integer. What's happening? What's happening here? Could anyone explain to me? Right? Well, why is X? Why it is X? Right? I mean, it's very common, right? If you're in generic code, you probably do something like this. My int AT, you see the C library, they would define something, right? Like type def, right? You think it's an int, but it's not int, right? You think it's my int 8. Why here it prints something quite weird? What? I don't know how to increase microphone. I tried, but I don't know. Here, is that possible? I really want to just enable that. It's just making myself be a little bit closer to that. Oh, probably. Oh, 200. Is that okay now? Is that better now? I don't know. Is that better? Let me try 1,000. Is that better? Probably too loud, right? Let me check it myself, okay? Sorry, but I shouldn't too yeah. Okay, 1,000. 1,000 probably. I think probably even larger. To 12. I'm late. Oh, not 1,000. LL Wolf. Yeah, I think it should be next time. Should be 112, something like that. 1,200, right? 12 times. So here, wait. Let's just go back to here. Right, those are issues I really hate. I don't. Now you have undefined behavior here. If we try sanitizers, we will see the bug here. But the compiler won't warn you, right? It won't warn you for anything. We will try to enable all the. Now you can see we have a crash here. But it's just nobody could even see what's going wrong, right? It's just real code. You can have issues like this, right? Yeah, you're gonna have issues like this, right? So, okay. Okay, if you think you're late, I'm gonna just repeat the experiment again. Just this is one, okay? I'm gonna run it wrong one for you. I don't know why so takes so long. Yep. And if I do Linux, yeah. See here, right? The format runs very slow, you know. Even with FMD compile, it still runs very slow. Yeah. So then you have crashing issue. Then you have format string bug. Tell me how this one is a good feature. I don't even understand why WG21 thinks it's a good feature, you know. It runs slow, it blows. Right, the binary size is ridiculous, right? That's why you see it's 206. Actually, it's not double. Oh, it's not double. Here, a megabyte, dude. A megabyte. Just remind me of Rust code will be taking me a megabyte for everything, you know. That's what standard library gives you. Okay, this standard gives you. Okay. Now you can see the last one do concat H string. Even concat WinRT string is 21. Right? Now they give you at least 88. At least 88. If you're static linking, you're gonna have a megabyte. If you try it with as in kernel, you cannot do this, right? I think this one is probably even running slower than concatting a CPP WinRT H string. We can try that. I think it's probably worth trying. Okay. Then we're gonna put something like include WinRT base WinRT H string. Then we're gonna do concat. Yeah, should be U16 concat, I think. What was the H string? Or just W concat H string? It's W concat. Don't do concat long, okay, just concat. This one probably even running slower than concatting a WinRT H string, you know. Which is a Y string, but it's probably gonna run slower, I guess. We're gonna try Microsoft compiler. Try here. We'll probably even try on ARM later. Okay, we can probably try on ARM. But we're gonna first try this one. Okay, don't do this. Okay, so there's some malloc here. Let me see any comments here. Oh no. Hey, is this something it's just annoying, you know, with the WinRT one, because it says tons of bugs. The Microsoft gives you tons of buggy crap, you know, just buggy crap. Unfortunately, so then we have to do that ourselves. By go here and change something. Right, go WinRT base. I last time I fixed it by just doing crazy tricks. 100, yeah, this one. This is just wrong. Okay, so we have to do something like if define plan. Then we'll do something else. Okay, we cannot do this, right? Because it won't be able to initialize the variable. Probably because of this. Let me see whether this one could work. Yeah, we need to retry it as administrator. Just annoying, you know. Microsoft gives you tons of buggy crap, you know. We just give you crap, right? No joke, just crap, right? This is just crap. We just first disable it, okay? Yeah, this should compile. What's going on here? Oh, probably I only tried concact len. I don't try concact. Okay, let's just try concact len. Okay, first try concact len. Okay, I'm gonna fix it later. Let me just. If we just one more, right? It's not an issue. WinRT H string. No matching function to copy. Oh, you know why? Yeah, it's L string. It's not. It's Y string. You know, the Windows use Y string, right? It doesn't use the normal string we're using, right? We're probably using this one. They're using L, so this is why it's not working. My code has no issue. Probably it's not even running slower than this one. So format is probably even running. Yeah, the format is running even slower than WinRT. You know, Windows runtime H string. You know. Yeah, my guess is perfectly correct. Correct. It's just running very slow. You know, the entire C+ standard library is just running very slow. Or just running slow. No joke, right? It's just running slow. Right? If you try to do Windows programming, you're probably going to do a lot of concact. If you're using something like W format, okay, let's try W format. But W format is still not H string, right? You're going to construct H string again after you do W format. W string. Yeah, W format. W format time. W format take W format times that, right? No W format. Or probably just format, but you put L, then it will be enough. Even the compilation speed is ridiculous, right? Let me see the binary size. It's just 400 kilobytes. I probably even put. Oh, probably I didn't put DLL. But it's still too large, right? It's just too large. The entire thing is too large, dude. I'm sorry to say that. The entire thing is too large. Right? 278. I'm not even include FMT, right? I'm dynamic linking. What? Why W format runs faster than format? Is it Microsoft? You are ridiculous, dude. You're ridiculous, Microsoft. Oh. Participate. Advent. I don't know what's that. Okay, no, sorry. Whatever. Just ridiculous. The entire thing is ridiculous. Don't do this, please, 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 no, please, please, no. Never do this again. Okay, I beg you, never do this again. 22. Tell me why. Why is 20? Probably we waste too much of resources, probably. Whatever, I don't know. Okay, probably it's to string. What's wrong with the string? Yep. Okay, we're gonna revert it. We're not gonna do this again. Revert it back. Okay, revert. So it's just it's bad, right? It's just bad. It's objectively bad, right? Disable it. Let me just try the binary side. If we just use file, okay, 17 compiled done. Compilation's done. 17 kilobyte. 17. Right. So you see the ridiculous here, right? What a standard just give you crap, literally crap. Now, if you just benchmark file, it's done. We don't have any crap here. It's done everything, right? It's yeah. So yes, stop using stool format, please. Never use this format. Just never use format. Okay, never use those things. Never use format string again. Please, okay, just never use format string again. So I think. Any questions? If no question, I'm gonna stop streaming. I have other things to do today. Can I just reduce some delay here? The delay is too long. No delay. I don't know how to even use it, to be honest. It's fancy programming. Yeah, probably just gonna stop. What's harvest that are good? Freestanding. Okay, freestanding one. Freestanding C++. That's the only part you can use. Okay, never use any features besides this one. And something like memory or tuple starts as C++ 23. So if you're using C++ 20, you use C++ 11, you can't use utility, you can't use tuple, you can't use memory, you can't use functional, you can't use iterator, you can't use ranges, you can't use ratio. Okay? This was standard out. Okay? Don't ask me. It's what standard did. Okay? Like you don't have, my favorite example is that address of. So you don't even have stood address of. You can't even get address from an object in C++ 11. Okay, you can't do that in C++ 20. You have to do that after C++ 23. Even getting address of an object, even getting pointer, even doing this, even doing this one, right? Which is what people would do first day when they write pointer, right? This is probably the first day you're gonna learn C, right? But in C++, you don't have that, you know. You cannot do this, you know. You cannot do this one. You cannot do this, you know. So I don't know. You should restrict yourself to freestanding headers, okay? Just so go freestanding header. I'm gonna send you a link here. Go to freestanding implementation. You go to the website. That's the features you should use. Okay. So any other questions? Oh, there's no exceptions, right? You have exception, but you don't have array. You see no array here, right? People you see vector, no vector. You never use those features. Okay. So, but when you're writing template code, it becomes very complicated, right? Think of fast I/O, right? I write a bunch of template code, then how can I do this? I need to execute a compile time, right? So when you're writing template code, it's gonna fuck you off. You should. The answer is that you should always use store address of instead of this one. Okay, I think we need to change in the future is that this sign, this and sign, should only be used for reference. Okay, and right then if you're gonna get address, don't do this because it's when I first learned C++, I get super frustrated by this thing, you know. Because you also have, right, something like this. People have no idea what's going on. What's the difference here? It's still frustrating when you first see the symbols in C++, right? So, what we should do is teaching new people never do this. Just do this, okay? If you want to get address, use a function. That function is a magic function that's gonna get you address. Think that way, right? If you're gonna get a reference, so this only means reference, right? Any other problems, right? And also don't have smooth, right? You have to write it by yourself. You don't have other features, right? You don't have array, you don't have span. Never you do. Those features does not exist. As you match the symbols, like to match. Whatever. I mean, it's not important, right? The problem here is that in C++ you shouldn't do this, okay? Because C++, you write a bunch of generic code finally, and those features are gonna fuck you up, right? This one is gonna fuck you, right? So there's no good way to fix it. Okay. Let me see whether I can put a delay in here. Put delay something like little, reduce some delay. No way, probably. I don't know. It just, right. You have to write the address of everywhere. So if you look at FastIO, for example, how many built-in address have I had? Just tons of built. You see 11 pages of built-in address of. Okay. Now, if you look at something like this, probably this is probably not a very good example. Okay, even calling that even with Win32 APIs, right? It's struct. Nobody is going to say it's not going to get not overloaded, right? Because someone is going to just do something here, right? You never know, right? So just always use built-in address for everything. Even calling function, you cannot directly calling function because exception will fuck you. You could define a magical function called no except call, but that's not in standard. But it's not okay in C++, right? That's the whole point. That's why C++ is bad for operating system. I'm not saying it's not okay to use it in C, but in C++ it's not, because the operator's address of can be overloaded in C++, right? That's why they have the built-in address of thing in the first place. You don't have that in C, right? So the entire code base is using built-in address of. The only place that I cannot use that, actually it's a clan thing here, is when I hack libc to C++, hacking the pointers. For example, hacking the function pointer, the v-table function, something like that, right? Now I have to use an address of that one. I think probably not in this file. If it's not in this file, it's probably in that file, in the libc++ here. Or it's Microsoft SDL. I'm gonna call the function. Let me see. I'll show you example. In that case, you cannot use address. I don't know whether send a bug, but in that case, you have to use a reference pointer. Yeah, here. Okay. Here is the only place you're gonna use this one in C++ to get address. Here is not actually getting address of an object. It's getting an address of a function pointer, a function. Okay. So here is a member function actually. Yeah, it's a member. It's a protected method. So what I'm doing is that I'm doing a private inheritance. I don't know whether you ever use private inheritance, right? People never use private inheritance. The reason you want to use private inheritance is that you can use using to expose some part of it instead of exposing everything. Okay, so private is actually pretty good if you're gonna use it with using. Okay, this is how you're gonna use private inheritance, and we're gonna, because there's two file paths. You go libc to C++. Go leave just some dirty hacks, but it's not uneven behavior, but it's a dirty hack. So we're gonna go for fstring. So we're gonna have file path, right? We'll have this file path thing here. Now it has all the protected method, right? Not just protected members, also protected method. Like some methods are very important, but I want to call it like this set of yeah. Those are methods all protected, right? All protected methods. Like this allocate buffer. It's a protected method, right? I need to use that API, but it's protected, right? You can use private inheritance instead of writing a bunch of Hebrew function in this exposed part of I don't understand your point. I don't understand why do this. You can use public. Actually, here you can do any inheritance. I don't think it makes a difference, but I would just use private here. Private inheritance. You can use public inheritance too, but I would just use private inheritance, so I only expose something I care about, right? Instead of exposing something else, right? I want to the reason I want using those things is I want to get the address and get this function pointer. Then I could do a context per leaf through fire buff to get the function point. This is function pointer to the member function. No? It's not a normal function pointer. It's a function pointer to a member function. Then this function can be used. This function pointer can be used for invoking virtual function calls. Then we're gonna call this with the pointer here. We're gonna dereference it. Okay. Then we're gonna just means we are actually calling the function by hacking it. When the compiler say, hey, you have a function pointer here, it sees the function pointer is optimized away, then just becoming a normal function call. Because here I'm doing is hacking the method because I cannot use it, right? If what I want to use a function method here is a protected method, how can we use it? I want to use this function method, but it's protected, right? If it's private, I cannot do anything. If it is a private method, I cannot do anything. But here is protected method. So yes, I can do something, right? So this is the only case you're gonna use this reference. It's the end, the end, right? An operator here is actually address of, right? To get address. In every other point, you're gonna do built-in address of, right? Like here we do built-in address of by hacking the. Actually, we can do this better. We can make this function better by hacking here, getting the offset instead of just calculating here. Here I'm doing a calculation, which is actually not good, right? I can make it better by moving it down and do something, right? But it doesn't matter here. If we're gonna do everything else, we're gonna use built-in addresser. But here we're gonna do something. Hack pointer and pointer, we're gonna do this, right? It's all hacking, right? I'm just thinking of memory base. It's just hack the file method. It's a protected method. Okay, and then hack it, right? Here it's gonna hack the data member, hack the data members, so we can just directly call in the function instead of writing again. Then this function is in the DLL. Then we will call the function in the DLL. Right. Now you can see it's just built-in address of bunch of built-in, right? Gonna calculate and just hack it. Allocate here and you could do something here. Just done, right? Allocate, set the buffer pointer, reset the buffer pointer, get it out. So then we construct after it. Yeah. So this is the only place you can do. So if you want to just call virtual method, call whatever protected method, you can do this, okay, by using a function pointer to hack it. To hack it, but standard doesn't want you to do that. But we want to hack it, right? We don't care about what OOP nonsense. I don't even use OOP in the library. There's no OOP in the entire FastIO. Just no OOP, no virtuals, that kind of thing. The only virtual I use is actually just some people really want that for their own devices. It's IO Fire, right? It's just they have a generic interface you can use. Even with this one, probably no virtual, right? I don't know. I don't see any virtual. Yeah, it should be a virtual here. But even in this one, it's not the way people would normally use virtual. It's not they are using virtual, and to be honest, I think the class should be just removed in the finally. But some people really say, hey, I just want a generic interface. They want to just put in a generic class so can write driver or something like that. I don't know. I never use it. Okay? I never use this class. Okay. So this is the only place you have virtual. Okay, this is only in the entire code base you have virtual. Okay. You don't have virtual anywhere else. Now then you have virtual query, right? That's just Win32 API. That's has nothing to do with C++ virtual. Okay. Like something like this. Oh. This needs to be revamped finally. because we cannot do X and C here. Okay, this is just code is wrong. It's just wrong code. Okay, don't do this. Okay, I'm going to fix it in the future. So this is just a memory file that allows you to open memory of other process. This is a very old code, probably 1 year ago. Very old. The code is very old. Probably 2 years ago. I don't know. Very, very old code. It shouldn't work this way. You just read process memory, but you can see it's just virtual we would use. It's to just deal with no C++ virtual, just other virtuals. Right. Well, this one probably going to remove too because I really don't want this in LCP. You can see it's coming out, right? It's not even really, they don't even really exist. I'm going to remove virtual all in the future for everything, no virtual. Virtual, just never use it, please. Okay, never use virtual. And I don't use unique parter too. There's no unique parter. You can see entire library has no this modern C, those no modern C++ thing, right? If you look at the random C++ library, they're probably going to use a bunch of unique parter. Let me try what about FMT? Do they use unique parter? Yep, bunch of unique parter, right? Oh, they format a unique parter. They don't use unique parter, but they do use unique parter. They do use unique parter. So we don't use unique parter at all. We don't need OOP. We don't need unique parter. We don't need any C++ shit, right? We don't use it. We don't use it, right? We don't use it. No unique parter. No array. Array I have to write my own. I can't use array. Oh, that's just example. They probably sometimes use it. There's no array besides examples. And also I don't even use this. This probably somewhere else, right? Yep. No array. Right. No standard array. Span. Okay, span. Span. Oh, what's this one? This is, here's an old one. I have to just finally deal with it. It's for async IO in fast IO. The async IO part. But the exceptions is really bad, so I finally just end up not doing anything. To class game dev, they shouldn't use those pointers, unique part or whatever. Even span, you shouldn't use it. Those are bad features, dude. This is just terrible features. There's no span. You can just row pointers. You can just, I'm just using row pointers everywhere. People are saying never use pointers, row pointers. You can see I'm using row pointers everywhere, right? There's nothing wrong here. Just row pointers every line. NT. I don't even think people could understand my code. They don't even know those things, right? Have you ever? I don't think anyone has seen some shit like this, right? Probably very few people never see it. NT create fire, right? Have you ever seen that? NT create fire. Yeah, this function, right? How do you create fire? All right. Yeah, so I'm programming very different than when people these C++ programs are doing, right? They're doing wrong. They're just doing wrong thing, you know. They shouldn't, right? Then even with DNS, we have no OOP, right? We have all the devices, but we don't have OOP. ESM, Bionic. Yeah, we even have Windows 99X DNS, right? We have Windows inside the network. Yeah, Windows 9X DNS. The DNS would work on Windows 95 with it. Okay, so if you're running Windows 95, FastIO could work on it. You never worked with Windows API before. You should. To be honest, I think if you want to program C++, you really need to understand Windows 32. It's just important, very important. You know. Right. The library, not even see Linux, we can see some Linux shit, right? Like some Linux specific shit, right? Like something like this, right? I guess you never heard of that either, right? Linux shit, syscall, right? We just invoke syscall to get into kernel. right? We don't like long arch. That's how fast I will enter the kernel. Even with entering kernel, I use syscall, the syscall instruction, right? Long arch is not a platform. Right? POSIX, right? NR, right? Bunch of NR, right? A bunch of NR syscall just go into Linux kernel, just getting into kernel without Linux, right? So yeah, I believe you don't even work with Linux either, right? You don't work with Linux, you don't work with Windows, you're just working with C++ garbage, right? That's what most people does, and most people do, and then they'll find it. Hey, I know C++. You don't. I know all sorts of zero cost abstraction and nonsense. It's so ridiculous, to be honest. They probably even never heard of anything I write here. The clock gate time, never, right? You can see I'm using measuring time here. I'm not even using any standard time thing. I'm just using the clock gate time. How could this even work on Windows, right? A clock gate time is a Linux thing, right? Right, you don't have that on Windows, right? You don't have clock gate time, but we are running it at Windows too. Any books? What book? Windows 32 or something? What book on Windows? I don't know. I suggest if you just want to learn Linux, go and read Linux. Just man is very good document. Just the man document, right? Man, right? For example, just we do something like this. It's gonna teach you a lot of how to use those API, like clock get time, clock tie, right? Clock tie, clock monolithic, clock boot time, right? Tie, I don't know actually. I actually probably need to do some offset. So, but tie clock. Some people are saying it's just going to completely get rid of leap seconds in the future, and then just making tie clock being real clock. But I don't know. Clock tie. They have to use macros, you know. Yeah, we don't use any macros. I just don't use any macros here. Right, we just do clock it time. You can use whatever you want. If you're gonna clock it time, clock it or whatever. Clock it time. On Windows, I emulate it. We do on the time here, the clock it time. On Windows, we're gonna do something like this. Okay. So according to the frequency, this is frequency. This frequency, but when we do something like thread, we're gonna get thread time, get process time, query count, performance counter. That's how you did with Windows, and I even have DOS. Here I have specific code to deal with DOS, to calculate the data time of DOS. I have specific code to deal with DOS. Okay. So yeah, and in other platform, we're gonna just do clock get time, libc clock get time. VDSO, we can just use VDSO here instead of just the clock get time. Yeah, just hack the symbol here. I don't want to include the header or just hack the symbol. Okay, any other questions? If we don't have, we just stop streaming. Probably no. Okay.